we have introduced what a function is. Now we're going to look at how to evaluate functions. We have done an example in the previous video. F of x equals 3x plus 2, and we can evaluate the function. Say if f of what f of 1 is, we just plug the number in, replacing x with 1, and we get 5, and so on. So now we can look at some more examples. So if we have a function, this time I'm going to pick a square root function, a radical function, and we can put, say, 4x plus 5. And if you remember that this function, square root function, whatever number you pick for x, you have to make sure after you plug in that number for x, 4x plus 5 is going to be non-negative. So it cannot be negative. If it's negative, it's undefined. Again, we only talk about real numbers. And so let's see if we plug in numbers. Let's say we want to find some values, g of 0, g of say 1, and maybe we can also do g of -1. Let's try to do a g of -2. So now make sure you remember that g of x is just a symbol to represent a function. Normally we use the first letter f, but if you can also use other letters, and g of x, they're together. It's just like the name of like our names. It's just in the name. Together it represents the function. So don't think of this as g times x or separated things. So they are always together. So let's see how we found a g of 0. When we look for g of 0, remember this number in the parentheses corresponds to the variable x. So which means in the function, that x is the same x as the x we have, is also going to be 0. So this 0 corresponds to that x, and that x is the same as this x. So that's why we can replace that x with that 0 we have. And then we have 4 times 0 is 0, plus 5 is 5. And square root 5 is already in its simplest form. We cannot simplify this any further. Now let's look at the second one, g of 1. So this time x is equal to 1. We're going to replace that x with 1. And simplify this. 4 times 1 is 4. 4 plus 5 is 9. And this one we can be simplified because 9 is 2 copies of 3. So square root of 9 is 3. Now let's do the next one. What if it's a -1? And we're going to replace that x with a -1. And simplify that. 4 times -1 is -4. -4 plus 5, I'm going to do one more step here, is going to be equal to 1. And the square root of 1 is equal to 1. And the last one, g of -2, we replace x with -2 plus 5. And we found that we have -8. 4 times -2 is -8 plus 5. That gives us a square root of -3. And this will be undefined because we have square root of negative number is undefined. So that means there's no answer for that. Or you can say no solution. Which means if you think of this function as vending machine and you put -2 into this machine, nothing will come out. But for the previous 3 numbers, when you put a 0 in there, square root of 5 is going to come out. When you put a 1 in there, 3 is going to come out. But when you put -1 there, then 1 will come out, but not -2. And you do have to remember that. So you may think square root function, it cannot be negative cannot be a negative number, but it's not the x value not negative. It's the whole expression with the radical sign together. 4x plus 5 cannot be negative. Notice that when I plug negative 1 into the function, negative 4 plus 5 still gives us a positive value. But when I plug in negative 2, negative 8, this is too small. Negative 8 plus 5 gives a negative value. That's why this one is undefined. So it's not like you cannot pick any negative numbers. Some of the negative numbers, when you plug in, may still give you a positive value after you multiply by 4 and add 5. Okay, and so this is the first example. We can do another one. And all right, so in this case, I have a linear function. There's no square root, there's no division, which means the domain is going to be all real numbers. You can plug in anything. But in the previous example, it's a square root function, and you got to make sure the number you plug in will not make 4x plus 5 negative. But this one, the only operations we have is multiplication and addition. We can do multiplication and addition with any number. Okay, so let's see. We want to find, for example, negative h of negative 4, and then h of maybe positive 4. And next we want to do h of a what if it's a variable or a letter? So h of a plus 2 and h of a plus h. Oh, well, I guess I already used h to represent function. Maybe I should use a different letter, h of a plus k. Okay, so there are 5 questions we have to do. So this is 5 different questions. Given one function, this x can be any number or letter. So that's why we have these different questions. So let's start with the first one. Let me write down the function one more time. H of x equals negative 3x plus 2. So when we do the first one, h of negative 4, which means, so this negative 4 corresponds to that x. And notice, remember, this x is the same as that x. So that means we are going to replace the x with the negative 4 given. As multiplication first, negative 3 times negative 4 is positive 12 plus 2. That gives us 14. Now let's work out the next one. What if we do h of positive 4? So at 4, we're going to replace x with positive 4 now. And negative times positive is negative 12 plus 2 gives us negative 10. And so these are the numbers which is this can be done similarly as the first example. But next example, then it's not a number anymore, it's letter A. But the idea is the same. So this A here corresponds to that variable x. And that x is the same as this x. So when I plug in, that we're not plugging a number anymore, we're plugging that variable A. So this x will be replaced by the letter A. And everything else stays the same. So negative 3 stays the same, time stays the same, but x is A. And negative 3 times A cannot be multiplied. Plus 2 cannot be combined because they're not like terms. So you will just have to leave your answer in like this. It's an algebraic expression. Now let's do, what if it's A plus 2? So we are going to replace, so what corresponds to x now? It's not just A, not just 2, it's together, A plus 2 together. So A will be, this x, letter x, will be replaced by A plus 2. So we're going to plug in there. We keep negative 3, but when I see x, I'm going to replace it with A plus 2. Because that's whatever in the parentheses corresponds to the letter x. And I'm going to keep plus 2. So the only thing you're going to change is that letter x. X is the variable that varies, that changes depending on whatever in the parentheses. So now we can simplify this. Distribute. Negative 3 times A minus 6, because negative 3 times positive 2 is negative 6. But there's another plus 2. And the like terms we have are these two numbers. We combine them to get minus 4. And now we cannot simplify this any further because they are not like terms. Now the very last question, we can, so this time the letter X corresponds to A plus K. So when we see the letter X here, we're going to replace that with the A plus K. So whatever in the parentheses replaces that X. So it replaces this X, which is the same as that X. And now we add that 2 in the function. Let's distribute. So we're going to get negative 3a minus 3k plus 2. Now there's no like terms to combine because a and k and 2, they're not like terms. None of these are like terms. So you will just have to leave the answer as it is. So if you are given some variables or different variables or letters, you would just have to replace that x with the new letter or variable. And so a little bit something else here. What I'm giving you here in the parentheses is a different letter. So this is not in the homework, but especially if you're going to take any higher level math like pre-calculus or calculus, you do this a lot. In the next section, we probably will also see this. And what if I give you h of x plus 2? How do we do that? Well, so there will be a little bit confusing. So there's x here, there's another x here. So are they the same x? No. So if in a given function, one function, this is all together. So this x must be the same as that x. But when you're given a different one, so this is a separate one from that, when they ask you what's h of x plus 2 is, and this x will not be the same as that x anymore. So what we're going to do is we're going to replace the whole thing, just like when we did a plus 2. So you're going to replace x with a plus 2. And so we are going to replace x with the x plus 2. So how do we replace x with the x plus 2? So when you see this letter x, you're going to put x plus 2 there. So x is replaced by x plus 2. And then you can do the same way and distribute, and you're going to get negative 3x minus 6 plus 2. And combining negative 6 and a positive 2, that gives us negative 4. If you compare this example that we just did with that one, the only difference is instead of having the letter A, we have a letter X. But the way we did is exactly the same thing. We replace X with A plus 2. Replace this X with A plus 2. But we replace this X with X plus 2. And you can see it's the same. The only difference is we have A here, but we have X there. And then you just distribute the same way, exactly the same thing. Combine like terms, exactly the same thing. And when you look at the answer, it's almost the same, except we have a in the answer, negative 3a minus 4, because we're given an a plus 2. And we have a negative 3x minus 4, because we're given an x. All right, so you can even replace x with a different x. So that's how we evaluate functions. Simply put, just plug in numbers or variable or letters.